Okay, so far in our algebra linear career here, we've talked about slope-intercept form, where they give you the slope and the y-intercept. We've talked about point-slope form, where they give you a point and the slope. And then the other form that we talk about is standard form. Okay, so there's these three forms that we have to be responsible for. Standard form is this one, and it looks just like this, so I'm pretty sure you've seen it before. The standard form is they do ax plus by is equal to c. Ax plus by is equal to c. Now, you have to know a few things. Okay, so a, b, and c, these are all real numbers. So a, b, and c are all elements of the real numbers. Okay, so that little symbol there is an element of. That means elements of. So that means a, b, and c are all real numbers. Okay, so they can't be non-reals like imaginaries or anything like that. And the other thing you have to know is that b, the way they put it is b and c. So b and c are not both. I'm not sorry. I'm not B or C. A and B. Excuse me. A and B are not both 0. Yeah, that makes more sense. Okay, let's ask that question. Why is it important that both A and B are not both 0? What if they were? What would we have?
0 plus 0 equals C.
Yeah, we'd have 0 plus 0 equals C. So that doesn't make any sense at all, right? So the A and B are not both 0 at the same time. So this is our working definition that we're going to be using for standard form. We have ax plus by plus, or ax plus by equals c. A, b, and c are all real numbers, and a and b are not both 0 at the same time. Otherwise, we wouldn't have something that works. Okay, what is standard form really useful for? Why do we want this? What is this useful for? Anybody know? Nothing? No. Why would it be in the book if it was useful for nothing? Okay? It's really nice when we are graphing. Okay? When we are graphing and when we're trying to find x and y intercepts. That's what this is really handy for. All right? So when we are graphing and when we're finding the x and the y intercepts, that's what we're going to use this for. Okay, so here's a great example as to why standard form is so nice when graphing. We're going to use it to find the x and the y intercept. We have 3x plus 4y equals 24, okay? First, let's recognize the fact that, okay, we have a value of a is 3, the value of b is 4, the value of c is 24. All of those are real numbers, and 3 and 4 are not both 0 at the same time. So far, so good. All right. How do you find a x-intercept? What do you normally do to find the x-intercept? You set y equal to 0, right? So you let y be 0. Okay, so to find the x-intercept, we let y be 0. So in this case, I would have 3x plus 4 times 0 is equal to 24. Why do we make the y 0 for the x-intercept? Why is that true? Yeah, we'll take a look at that on the graph in just a second. For every point that crosses an axis, right? If it's on the axis, one of those points has to be 0. So we're finding the x-intercept, the other one has to be 0. We're finding y-intercept, the x has to be 0. Yes, Daniel.
If the x and y are both 0, then what do you write past that?
You would just get like 0 equals 10, which is not a true statement. Yeah, you wouldn't say anything like that. Okay, so if we keep going with this, we get 3x is worth 24 if I divide both sides by 3. Divide both sides by 3, I'm getting that x is worth, how much is 24 divided by 3, everybody? 8. It's worth 8. Okay, good. X is equal to 8. What does that mean? Okay, so the x-intercept is 8. How do I write it as a point, as a coordinate? Yes, okay, remember it's x, comma, y. Well, we just realized that the y was 0 and the x-intercept is 8. So this is the thing that I am looking for here. I'm looking for 8, comma 0. Okay? Now, how do I find the y-intercept? What do we do? Yeah, we let x equal 0. Exactly. So I would have this. I would have 3 times 0 plus 4y is equal to 24. So I would get 4y is worth 24. I would divide both sides by 4. And I would get y is equal to, how much is 24 divided by 4? I would get 6. So what do I want in terms of my point? Very good. It would be 0, 6. And so look what you have now. Okay? Without doing a whole lot of work, we have these 2 points. We have 8, 0 and we have 0, 6. Why is that useful for us? Because now we can quickly and easily make a graph. Watch how easy this is, okay? I want 8, 0. So I go 1, 2, 3, 4, 5, 6, 7, 8. 8, 0 is the point right there. So I label 8, 0. All right? And then I want 0, 6. So 1, 2, 3, 4, 5, and 6. There's the point 0, 6. Notice I've labeled both of them. How many points do you need to make a line? 2. You need 2 points. Do I have 2 points? Yeah. I certainly do. I have enough information to make a quick little sketch of that line like that. Okay, so to check this, let's make sure we did this right. So we had, it was 3x, right? Plus 4y is equal to 24. Is that right? Is that what we had? All right, so if we graph this really quick, obviously this program works a lot faster than we can, but the points that we come up with that we can see are clearly right there, 8, 0 and 6, 0. So I would say that that graph looks a whole lot like that graph, and we did it right. Okay, this is a U-try, so all I want you to do is find the x and the y intercepts of the graph. You do not need to make a sketch, just tell me the x and y intercepts of both. Ready, set, go. All right, quickly, so who can show us what they did here? It looks like I walked around almost everything right. Evan, what did you do for the first one, part A? What did you do, buddy?
I did, to find the y-intercept,
yep.
I inserted 0, like I substituted it for x.
Mm-hmm.
And then I got negative 6y equals 60.
Yep.
I divided both sides by negative 6, and I got y equals negative 10.
Y equals negative 10. So what does that mean in terms of the intercept there?
It means like the y-intercept is negative 10.
Yeah, so how do I write it as a point if the y-intercept is negative 10? How do I write it as a point?
0, negative 10.
0, negative 10. Good. What about the x-intercept?
I inserted 0 in for negative 6y.
Mm-hmm.
I got 5x equals 60.
Yes.
And then I divided that.
Yep.
And I got x equals 12.
X equals 12. So what would the point be for that one?
I wrote it as 12, 0.
Perfect. So these are the answers that we're looking for right here, right? The points. Okay, part B, we do the exact same way. So what did you guys get for the x-intercept here? Just quickly, tell me what your answer was. 4, 0. Does everyone agree that should be the right answer? 4, 0. And what did you get for the y-intercept for that one? 0, 1.5 or 3 halves, whichever one you have would work fine for me as well. Okay, so we're going to graph together x minus 2y equals negative 2. X minus 2y equals negative 2. Now this is in standard form. X minus 2y equals negative 2. So we're going to go ahead, and the first thing that we're going to do is we're going to get the x and the y-intercepts. All right, the same exact way that we just did. So for the x-intercept, I'm going to have x minus 2 times 0 equals negative 2. So x is just equal to negative 2. So I have the point there as 0, negative 2. For the y-intercept, I'm going to do the same thing. I'm going to let x be 0. So I get 0 minus 2y equals negative 2. Divide by negative 2. So I'm getting what, y is equal to 1. So that would be the point 1, 0. Okay, now that I have my 2 points there, right, what I want to do is I want to graph them. And we're going to graph them all you do is graph those 2 points, okay? So give yourself a straight edge and make yourself a coordinate plane. A straight edge?
Yes. Yeah, I cheated.
One of my inspirational straight edges? That's okay. They weren't very inspirational? Oh, okay. Yeah. Hey, thanks for pointing that out. Those are written backwards, so we fixed these. So this is the x, this is the y, this is the x, this is the y. Okay. All right, now that we have these two, all we got to do is plot them and feel good about ourselves. So x is negative 2, 0. So negative 2, 0, that'd be this point over here. And then if I want to go graph the y-intercept, I have 0, 1. So that would just be that point right there. All you need is 2 points to make a line, and we would have this line right here. Yes, those were written backwards. Sorry, thank you for catching that. I had these reversed. All right. So to check really quickly, we have x minus 2y equals negative 2. Let's make sure we all have the same graph here. So if I've got x minus 2y equals negative 2, Let's make sure that our graph looks like their graph. Yes, absolutely, it's always a good idea to check. Look, you can clearly see the intercepts are exactly what we got as well. -2, 0, and 0, 1. So that graph and this graph look the same.
I like that app.
Okay, so we're going to graph horizontal and vertical lines, all right? So one of these is horizontal, one of them is vertical. What do you think happens a lot in an Algebra 1 class when people try and graph x equals 3? They make it horizontal, right? Okay, why do they make it horizontal?
Because the y-axis like this, so you're going to do it.
Is that why they make it horizontal? Okay, well, how do we graph the line x equals 3?
Put a point on
How do we graph that line? X is equal to 3.
3, 0, and make it vertical.
Yes, okay, here's the line x equals 3. So 1, 2, 3, 4, 5, whatever. Okay, so here's 3, right? Here's when x is equal to 3. So that would be this line right here. Okay, here's the line x equals 3. Why do you think most people make that line a horizontal line? If you had to take a guess. Because it would make sense to match the x with the same x-axis. That's what most people think, okay? So why is x equals 3 a vertical line? Why is that?
Because this,
What do you think, Brandon? Why?
Because there's no y and there's no slope.
There's no slope. What do you think? You guys are on the right track. Alice, what do you think?
Because for every possible value of y-axis, always going to be 3.
There you go. That's it. That's the real reason why it's a vertical line. So let's take an example here. Okay, give me the coordinates of that point right there. What would it be? 3, 1. Give me the coordinates of this point right here. What would it be? 3, 3. Good. Give me the coordinates of this one way up there. What would that be? 3, 1, 2, 3, 4, 5, 6, 7. Okay. What are you noticing that's in common with every single point that we just did? The x value is always 3. Now, is that true for every single point on that line? Yes, the x value is unchanged. So regardless of what y is, the x value will always be 3. That's what makes that line vertical. Okay? So by the same logic, if I was going to graph the line x or y equals 3, what would this graph look like? Horizontal or vertical?
horizontal.
Let's be horizontal. And how would I graph it?
Make a point
0,
at 0, 3.
Exactly. This would be a horizontal line. Here's the line. Y is equal to 3. And for the same exact logic, no matter which point that you put right here, right, you'll always have something, comma, 3. The y coordinate will always be 3 no matter what you do. Okay, for that. All right? Okay, here you go. I give you 4 little tiny itty-bitty equations. I want you to make quick little sketch graphs of each one, okay? Quick sketch graphs of each one. Ready, set, go. Okay, so let's see here. You should have, let's see if I can graph all these at once into one thing. Yeah, we can. Look at that. Check that out. Okay, so you guys should have all of these graphs here. The red graph is x equals 4, so it should be a vertical line over there at 4. The blue graph is x equals -1, another vertical line. The black line is y equals 1, which is a horizontal line up there at 1, and the green line is y equals 0.
Oh, 1 on y is 0.
Y equals 0. Yep, there it is right there.
It was a 6.
Okay, so last example of this lesson is we're going to take an equation, we're going to write it in standard form. That's what SF means, not San Francisco. Standard form using integers, right? So here we go. If I gave you this one, everyone always says that's San Francisco. So, okay, so y is equal to, let's do negative 3/7 x plus 5, okay? What form is that in right now? Point slope or slope intercept? Slope intercept. Very good, everybody. Okay, we want to turn this into standard form. So we're trying to get this equation to look something like this. AX plus BY equals C. That's what we're looking for there, okay? How are we going to do it? Yeah, what do you think, Will?
3/7 x to the y side.
I'm going to actually do something else. I want to use integers, right? I want to use integers. So what do I want to do first?
You want to multiply everything on 7.
Yes, there you go. Multiply everything by 7. Why by 7? I don't get it.
To take away your fraction.
Very good. So take away our fractions. Good. Okay. So here's what I end up with. I would get 7y is now equal to negative 3x plus how much, you guys? Plus 35. Good. Look, so in one little operation there, it's starting to look more like ax plus by equals c when we're using integers, right? What's my next move? Who's got it? Add 3x, right? So I would get 3x plus 7y is worth 35. And that's what we would have to begin with, okay? So it looks kind of weird, but look, we'll prove it to you really quickly because it's always good to do this. So if I take the equation, y equals, if I want negative 3/7 x plus 5, okay? And then if I graphed, what did we come up with? 3x, what was it, you guys? Plus 7y equals what? 35. Okay, look. So, oh, this doesn't look right to me. 7, this doesn't look right to me. 7y. Whew. 7. There we go. Okay, so look at these two, right? They don't look anything alike. Y equals negative 3/7 x plus 5, and then 3x plus 7y equals 35. But when you graph them both together, they only make one line. You see that? So even though they look different, even though their forms are different, right? No matter where I am here, if I zoom way out, right? They still only make one line. So lines can have different forms, right? They could have point slope form, slope intercept, and standard form. They all generate the same graph.